Hello, my name is Professor Adjavan, and this is episode 17 in the Quadratic series. In this episode, we're going to be looking at, again, how to graph a quadratic. This time, we're going to be looking at quadratics that are in the factored form. We're going to do 3 examples in this video. The examples are on your screen now, so if you're doing some homework problems that look like these, this is the correct video for you. If you're confident that you can graph these problems by hand without a graphing calculator, I would recommend going on to the next video in this series. For everybody else though, we're going to go ahead and jump right into it. So in the last video when we did standard form quadratics and we graphed them, it was really easy to get a couple of things. It was really easy to get the y-intercept because that was just c, and it was also easy, a little bit of work to get the vertex because we had that formula of negative b over 2a and then plugging it in. So for each of these forms of quadratics, when we go to graph them, there's a couple things that are easy to find and then a couple properties that are a little bit more involved. So with factored form, we should remember from solving quadratics that factored form is beneficial in solving because we can set this equal to 0, solve for x, and that will be our x-intercepts. So if we set this equal to 0, we can easily solve for x by looking at when is x minus 3 equal to 0 and when is x minus 4, x plus 4 equal to 0. Adding 3 to both sides, we get x equals 3. Subtracting 4 from both sides, we get x equals negative 4. So these are our two x-intercepts. So 1, 2, 3, 4, and 1, 2, 3. So we have, so we're going to label everything. The x-intercepts are 3, 0, negative 4, 0. Y-intercept is pretty straightforward. We're just going to take the two numbers, not the x's, but the two numbers, negative 3 and 4 in this case, and we're going to multiply them. Negative 3 times 4 is negative 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, all the way down here. And again, we can label this y-intercept is at 0, negative 12. So why do I just get to multiply these two numbers to get the y-intercept? Well, if we were to FOIL this out completely, the negative 3 times the 4 would be the constant term on the end of the quadratic. There would be no x's with it, meaning once it's in standard form after foiling, it would be the c term. And we know from the last video that the c term, the constant term in a standard form quadratic, is the y-intercept. So rather than foiling this out completely, we can just go ahead and take the two numbers, the two last terms in our binomials, and multiply them to get the y-intercept. Alright, so we have x-intercepts, we have y-intercept. We need the vertex. So how can we find the vertex? Well, we don't have any formula like we did in the last video with standard form. We need to think about properties of parabolas and quadratics. Quadratics are symmetrical. They are symmetrical across the line of symmetry, the axis of symmetry, and the axis of symmetry goes through the vertex. So because they're symmetrical, if I look at my two x-intercepts, exactly halfway between this, there should be a vertical line of symmetry, meaning our vertex is halfway between these two x-intercepts. So if I take a concept like the midpoint, right, finding a midpoint, you add the two x values and you divide by 2. So if I take the two x values of my x-intercepts, negative 4 and 3, and I add them together and divide by 2, I can get the x value of my vertex. So negative 4 plus 3 is negative 1, over 2 is negative 1/2. So I have a axis of symmetry at negative 1/2, and that means that my vertex is somewhere on this axis of symmetry. To find out where it is, I simply need to plug it into the equation. So if I plug it in, negative 1/2 minus 3 is going to be negative 7/2, and negative 1/2 plus 4 is going to be positive 7/2. Multiplying these two together, we're going to get 49 over 4. Negative 49 over 4. And I like leaving these as fractions and not writing them as decimals. So what is this? Well, 48 over 4 is 12. And then I'm left with 1/4. So we're at negative 12.5. My y-intercept is at negative 12, so I just need to go down a little bit more. And I have my vertex. So the vertex is at negative 1/2, negative 49 over 4. Now all that's left to do is connect my points. Alright, good enough for me. Alright, let's label a couple of other things. We already found that the axis of symmetry is at x equals negative 1/2. Domain. We know that the domain is always negative infinity to infinity. And the range, because this parabola is pointing up, is going to be from our bottom, which is at the vertex, the y value of the vertex, negative 49 over 4, all the way up to infinity. Alright, so we have our parabola graphed, we have all of the appropriate information labeled, and we have all of the supporting work shown. So let's move on to another example. We're going to start this one exactly the same way, setting it equal to 0 to take advantage of it being in a factored form so that we can solve for x. So when is 3x plus 5 equal to 0, and when is x minus 1 equal to 0? Well, if we subtract 5 and then divide by 3, we get negative 5/3, and then if we add 1, we get positive 1. So we have negative 5/3, right about there, and positive 1 right there. To find the y-intercept, I want to multiply the last term of each binomial together. 5 and negative 1 make negative 5. Negative 5 is my y-intercept. 1, 2, 3, 4, 5. Plot the point, and let's make sure we're labeling all of the important information. So our x-intercepts are at negative 5/3, 0, and 1, 0. And our y-intercept is at negative 5, 0. Let's flip those. 0, negative 5. There we go. Now the vertex. So to find the vertex, we take the x value of both x-intercepts, 1 and negative 5/3, and we are going to add them together. And then divide by 2. So 1 plus negative 5/3 is going to give me negative 2/3. And dividing this by 2, dividing a fraction by 2 is the same thing as taking the fraction and multiplying it by 1/2. So we end up with negative 2 over 6, or negative 1/3. The x value for my vertex is at negative 1/3. So I can say my axis of symmetry is at x equals negative 1/3. And then to find the y value, we're just going to take negative 1/3 and plug it into our function. So f of negative 1/3, plugging it in for x. Well, 3 times negative 1/3 is negative 1. Adding 5, we get negative 4. And negative 1/3 minus 1 is going to give us negative 4/3. This negative 4 can be rewritten as over 1 so that we can have two fractions and multiply straight across the top and straight across the bottom. So negative 4 times negative 4 gives us positive 16. 1 times 3 gives us 3. 16/3 is going to be the y value, which doesn't make sense, does it? Because that means it's going to be up here and our y-intercept's way down there. So where do we make a mistake? 3 times negative 1/3 is negative 1 plus 5 is positive 4. There we go. So this is negative 16/3. That makes a lot more sense. So negative 16/3 is a little bit more than negative 5. So we're right down here. Now we just have to connect all of our points. Good enough for me. I'm not very strict with my students' parabola drawing skills. That's why I always label all of the important information. Our vertex, for example, is at negative 1/3, negative 16/3, and our domain is always, always, always all real numbers, negative infinity to infinity. And our range, because we are pointing up, is going to be from the y value of the vertex, negative 16/3, all the way up to positive infinity. We have our parabola sketched, we have all of the appropriate information labeled, and we have all of the supporting work. All right, we have one final example. Starting it exactly the same way, setting our factored form equal to 0 to take advantage of the zero product property, which says I can take 2x minus 1 and set that equal to 0, and I can take x plus 3 and set that equal to 0, and solve. So if I add 1 and then divide by 2, we're going to get 1/2, and subtracting 3, we get negative 3. So our two x-intercepts are at negative 3 and 1/2, so we can label that x-intercept at negative 3, 0, and 1/2 is 0. Our y-intercept is taking the last term of each binomial and multiplying them. So negative 1 times 3 is negative 3. Y-intercept at 0, negative 3. And then if we take the x value of the x-intercepts, negative 3 and 1/2, and we add them together, and divide by 2, meaning we're finding the midpoint between them, we'll get the axis of symmetry and then be able to find the vertex. So negative 3 plus 1/2 is going to give us negative 5/2 over 2, and again taking a fraction and dividing by 2 is the same thing as taking a fraction and multiplying by 1/2. So this gives us negative 5/4, which is a little bit more than negative 1. So I have my axis of symmetry at x equals negative 5/4. And to find the y value of the vertex, we just need to plug that value into the equation. So f of negative 5/4, plugging it in for all of the x values. Well, 2 times negative 5/4 is going to give me negative 5/2 minus 1. And negative 5/4 plus 3. Let's just go ahead and rewrite this. Negative 5/4 plus 12 over 4. So negative 5/2 minus 1 will be negative 7/2. And negative 5/4 plus 12 will be there we go. Negative 5/4 plus 12/4 will be 7/4. Multiplying straight across the top and straight across the bottom, we get 49, negative 49 over 8. Well, 8 times 6 is 48, so it's a little bit more than negative 6. So 1, 2, 3, 4, 5, 6, and a little bit more right about there. Now we just need to connect all of our points. Good enough for me. If I had one of my students draw this and all of this appropriate information is labeled, I would give them full credit. The vertex is at negative 5/4, negative 49/8. Domain, always, 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 all real numbers, negative infinity to infinity. And again, we have a parabola that is facing up, so it's going to be from the y value of the vertex, negative 49 over 8, all the way up forever and ever and ever, all the way up to infinity. Again, we have all of the appropriate information labeled, we have a sketch of our parabola, and we have all of the supporting work to go with our answer. Alright, hopefully this helps you be able to graph quadratics and label all of the information for quadratics that are in factored form. The previous video was graphing them in standard form, and the next video will be on graphing them in vertex form. If this video was helpful, consider giving it a like. If you have any questions relating to what was covered in this video, feel free to comment it down below. And if you have any suggestions for something you want me to cover in the future, go ahead and comment that as well. And consider subscribing to get some more math lessons. Thanks, and we'll see you in the next one.